Let us study the topic gravitational waves. Normally, we people all are knowing about the meaning of waves. Sea waves all are seeing it. Now even in a pond or wherever a stable condition water is there, we can say that in a bucket full of water is there, if you are putting a stone, we can find that there waves are occurring. Similarly, sea waves all are seen, all are knowing about it. Now we people are heard about electromagnetic waves. Electromagnetic waves are of different types. We can say radio waves, microwaves, then we can say gamma rays, then X-rays. All these things are different types of electromagnetic waves. Now recently only we came to know about the gravitational waves. Gravitational waves are very weak waves. In 1916, Einstein predicted about the presence of gravitational waves. Now gravitational waves we can call in other name, that is fabric of space-time. So gravitational waves we can call in other name waves we can call in other name, that is fabric of space time. In which year is due? 1916. A scientist, his name is what? Einstein. So in 1916, a scientist, his name is Einstein, E-I-N-S-T-E-I-N. He just predicted the presence of gravitational waves. Exactly after 100 years. We can say that after 100 years means 2016. Scientists discovered what are really gravitational waves. For its discovery, even Indian scientists contributed so much for it. For its discovery, Indian scientists worked a lot. Now, for detecting that it is very weak waves, it is producing by astronomical objects like we can say asteroids, meteors, then we can say different planets. Like that way, we can say that this gravitational waves are producing by different astronomical objects. They are producing very weak energy or weak waves only they are producing. For detecting that, very much sensitive instruments detected by or made by or constructed by different scientists. Out of them, very important, very sensitive instrument is LIGO. L-I-G-O. It's a full name. All letters should be in capital. Now, its full name is Laser Interferometric gravitational waves observatory. For constructing this instrument, our Indian scientists worked a lot. Even with the help of this instrument about gravitational waves, lot of studies they done. Plus we can say that this study helped all scientists to detect more and more about the astronomical objects. Now we will study about other topic, what is freefall, as well as after freefall we will study weightlessness. Why? Because both of them are having little relation. Now first we will study what is free fall. For example, from a mango tree, a mango falls. When a mango falls from a mango tree, straight, that means a perpendicular direction, it falls. Now, why it is falling? That is only because of the attractive force of the earth. If an object is falling down, that is only because of earth's gravity. There are no other forces acting on it. Then we can say that that is the free fall of the object. Now we can say what is the definition of free fall. Free fall means what? It is a kind of motion. That motion is happening only because of the action of the earth's gravity. Now you see here mangoes falling, I said, even apples falling, any other fruits are falling from the tree directly towards the earth's gravity. But problem what is there? When they fall down, air, it prevents the motion of the objects which are coming from up to down. So here now I am saying you, big objects, heavy objects will be there, air gives way. That means it will fall. But at the same time, lighter objects will be there. Suppose feather is there, or we can say any particles, light means dust particles, such a light particles will be there. So they cannot be able to fall directly to the earth. You can find that they move here and there without falling. That is only because of the earth's air, because of the resistance, or we can say because of the frictional force as well as the buoyant force exerting by the air. Now I am explaining what is frictional force. As well as buoyant force. Frictional force means it does not allow any object to move. For example, we can say if any object we move through the rough surface, that object cannot move in a speed way. If there is a smooth surface, the object can move easily. Roughness will be there, that is known as a friction. Similarly here, if an object is falling down, the air itself does not allow that object to pass through. So that force is known as frictional force. Now buoyant force means upthrust. Buoyant force we can call it in other name, that is upthrust. Upthrust means upward force. Upthrust, or I am calling it as upward force. When an object falls down, air does not allow the object to pass through, one thing. Second thing, it will prevent the movement of the object from falling top to bottom, or when it falls from up to down, it will push the object to upward direction. That is known as a buoyant force exerting by the air. Now I am saying you one more thing. As I told you before, heavy object will be there. How much means resistance power exerting by the air, no value is there, it will come down. But at the same time, if there is lighted object, if air exerts force against its motion, that will work. Now I am saying you, if there is no air in the atmosphere, we can say that is vacuum situation will be there. Then I am saying you one example. This is the surface of the earth. Two objects. One I am saying you feather. Other object I am saying you a heavy object. Any heavy object. It is suppose stone. Both of them I am keeping at the same height. If I am releasing both the things down at the same time, in case if there is a vacuum situation means what, children? Vacuum means there will be no air. Such a situation will be there. You can find that both the objects, feather means a very thin, light object, other thing very heavy object, you can find that both of them will fall with the same speed. That is only because of Earth's gravitation. Here only Earth's force is acting, no other force. No air, no other force, only Earth is pulling that object. So we can find that Earth's pull towards each and every object at a distance from the Earth will be same. So we can say that the force of gravity on whether it is heavy object, whether it is light object, it will be same. So we can say that force of gravity will be same on, will be same on all objects at the same height. At the same height. Now children, we people are studying about other topic, that is what is meant by escape velocity. So before that, as I told you, I'll explain weightlessness. Weightlessness also happening because of free fall. Free fall we studied. For free fall only one force is acting on the object, that is Earth's gravitational force. Now we are studying about weightlessness. Weightlessness is happening only in the space where only the Earth's gravity acts. You can find that. Now when we study about the weightlessness, with one example I will explain. Weightlessness. Weightlessness is happening where? In the space. There so many space vehicles are moving. Spacecrafts will be there. So we can say that one example, rocket. We are sending rockets towards the space. Once it reaches at the means particular distance, we can say in the space, it orbits anywhere, means once it reaches at the space, it orbits at a particular distance, then it starts to revolve around the Earth. We can say one example I am saying you. Here now Earth is there. We people are sending a space vehicle, spacecraft or a rocket into the space. You just imagine that object reached at this particular spot. Once it reaches there, it starts to revolve around the Earth. It keep on revolving around the Earth without increasing its speed, without decreasing its speed. How it is possible? That is only because the Earth's gravitational force. Normally we say when an object which goes into the space, there will be no gravitational force. But children, there is gravitational force. Now you see, this object reached here, this particular spacecraft reached here. Now it finds its own way to revolve around the Earth. Here, what I am saying you, gravitational force, I told you gravitational force is exerting by the Earth towards this object. It is not zero, it acts. Now how much it acts, that I am saying you, gravitational force acting by the Earth on such a spacecraft, space vehicles, that is only 11% less than the gravitational force exerting by the Earth when any object will be on its surface. I am saying you, Gravitational force means its symbol is small g. On the surface of the earth, the gravitational force acting, that is equal to 9.8 meter per second square. Now what I said to you, gravitational, that is on the surface of the earth. Gravitational force acting on the surface of the earth is 9.8 meter per second square. Gravitational force is acting by the center of the earth. Now what I said, here one spacecraft is orbited. Now it started to move. So towards it, the earth acting its gravitational force. That I can say you approximately 8.772 something like that. This much a meter per second square. So what I am saying you here, the difference how much is there here? 9.8 meter per second square. At the same time, on spacecraft, what is the gravitational force? 8.7 something. So we can say that the difference between Earth's surface as well as on the spacecraft only 1 meter per second square. It's the difference only is there. So we cannot say that there is no gravitational force acting on spacecrafts or the satellites which we are sending towards the orbit of the earth. Now we can say that here we people already studied about this thing. That means now gravitational force is there. One more question. When gravitational force is exerting on these objects, so there will be pull. That is true. There will be pull on these objects from the center of the earth. Another thing what I am saying you, even though this object is not falling down. Why it is not falling downwards? That is only because of the free fall exerting by the free fall means what? The motion of the object. Free fall means motion of the object. Here which is the object? That is the spacecraft. On that free fall is occurring. Free fall means attraction or the pull is taking place from the earth. But one more question. Why it is not falling down to the earth? Its answer, this object is continuously moving. It does not have any stop. But its movement will be with the same speed, but it moves continuously around the earth through a particular or specific orbit. Because of its motion, it is not falling. One more thing, when we speak about the free fall of an object, when the object is at rest, then we release it, then only it fall down. If the object is in motion, it does not fall. So we can say that which all objects are there in the space, they won't fall down till they have movement. Once their movement stops, then it will fall down. Why? Anyhow, earth is pulling them. So because of that only we have fear that any object will fall down to the earth or not. But until and unless they stops working, they won't fall down. Now another thing, when we people, suppose we are there in that spacecraft, in that rocket, if we are there, we put any object down, but that object does not fall down. It will remain anywhere. Where we are putting, there it remains. Again, when we are touching that object, we feel it has no weight. Because of that, saying that in the space, any object will be there, they feel that, they experience, they have no weight. So that feeling, that is known as a weightlessness, that is happening only because of the free fall which is happening. Free fall means what? The motion of the object which is happening, that is only because of the force acting by the earth.